Hi everyone, I am Dr.I.JANNATHUL FIRTHOUSE, Assistant Professor of Mathematics, A.D.M.COLLEGE for Women, Autonomous, NAGAPATTINAM. Today we will discuss about the topic dual simplex method in operation research. We know already the simplex method. In previous class, we will discuss about the simplex method of the linear programming problem. What are the conditions? The problem is to be maximized. Maximize is equal to some constant. And the subject to the constraints or x1 plus x2 must be in less than or equal to constraints. So the given condition is the given question is minimize z equal to 3x1 plus x2 and the subject to the constraint is x1 plus x2 greater than or equal to 1 and 2x1 plus 3x2 greater than or equal to 2. So you have to convert the minimize z is to be maximize z. So minimize z is equal to minus of maximize z. So what a maximize z is equal to minus 3x1 minus x2 and the given subject to the constraint you have to convert greater than or equal to is to be less than or equal to. So minus x1 minus x2 less than or equal to minus 1 and minus 2x1 minus 3x2 less than or equal to minus 2 for all x1 comma x2 greater than or equal to 0. For all x1 comma x2 greater than or equal to 0. Now we have to introduce the slack variable for transforming the less than or equal to is equal to. So if you put that slack variable minus x1 minus x2 plus x3 equal to minus 1 minus 2x1 minus 3x2 plus x4 is equal to minus 2. So what are the slack variables? x3 and x4. x3 greater than or equal to 0 and x4 greater than or equal to 0. The slack variable is a dummy variable. Okay, so the maximize z is to be changed. Maximize z is equal to minus 3x1 minus x2 plus 0x3 plus 0x4. So what it means? Because the 0 means dummy. So the x3 and x4 is a slack variable, x3 is a dummy variable and x4 is also a dummy variable. So you put it in the matrix form, that is Ax is equal to B. What is here? A minus 1 minus 1 1 0 minus 2 minus 3 0 1 and what are the variables? x1 x2 x3 and x4 is equal to B. What are the constant values? Minus 1 and minus 2. These are all the previous steps before we are going to solve the problem in dual simplex method. First, you have to convert whether the problem is minimized. You have to change the minimize is to be maximized. That is, you convert the sign in all the variables. And the maximize is equal to minus 3x1 minus x2 and the subject to the constraints you have to change minus x1 minus x2 less than or equal to minus 1 minus 2x1 minus 3x2 less than or equal to minus 2 x1 comma x2 greater than or equal to 0 and you have to convert the less than or equal to into equal to by introducing the slack variable x3 and x4. So minus x1 minus x2 plus x3 equal to minus 1 minus 2x1 minus 3x2 plus x4 is equal to minus 2 x3 and x4 the dummy variable greater than or equal to 0 So maximize z is equal to, the given maximize z is equal to minus 3x1 minus x2 plus 0x3 plus 0x4. Ax is equal to b. Now we will solve the problem in a tabular column. Now we apply all the values in this method, in this iterative method, that is CB, YB, XB. How many variables are there? X1, X2, X3, X4. We convert into Y1, Y2, Y3 and Y4. And the A value, that is in matrix form, minus 1, minus 1, 1, 0, minus 2, minus 3, 0, 1. The B value, that is the minus 1 and minus 2. What are the values given in maximize z equal to minus 3, that is the maximize z equal to minus 3x1 minus 1x2. So we put it in these values minus 3 and minus 1, and we convert the sign minus into plus and the plus into minus. In this problem both the values are minus. So we convert plus 3 and plus 1, that is Zj minus Cj. So now in simplex method, you have to first of all you have to concentrate the Zj value, Zj minus Cj value. We choose the most negative, that is the least negative or most negative. In a dual simplex problem, that is a reversible simplex problem. So you have to see the xb value. You choose the most negative. Which one is the most negative value? Minus 1 and minus 2 compared to minus 1 and minus 2. Minus 2 is the most negative. So you obviously you have to choose the Y4 row. So in simplex method, we first of all we choose the column. Next we choose the row. In dual simplex method, it is the reverse process of simplex problem. So first of all, you have to choose the row. So how can we choose? You see the xb value. In xb value, you select the most negative value. The most minus 1 and minus 2 compared to minus 1 and minus 2, the most negative value is minus 2. Most negative. So minus 1 and minus 2 is the most negative. Minus 2 is the most negative. According to that, you select the row Y4. So now we have to select the column. So how can we select in simplex? First of all, you have to select the column and then you select the row xb value divided by choose the column. So this is the reverse process of the simplex problem. So Zj minus Cj value divided by choose the row. So maximum of 3 divided by minus 2 and 1 divided by minus 3. So minus 1.5 minus 0.3. So which one is the least negative? Which one is the most negative? So you have to select Y1, least value. So you have to obviously select the row column Y2 column. So minus 3 is the pivot element. Minus 3 is the pivot element. Minus 3 by 2 is minus 1.5. 1 by 3 is minus 0.3. So maximum value is minus 0.3 is the maximum. So you have to choose the Y2 column. So maximum of minus 3 by 2, minus 1 by 3, minus 1.5 and minus 0.3. Which one is the maximum for these two value. Minus 0.3 is the maximum value. So minus 0.3 occur in the second column. So you have to select Y2, and obviously minus 3 is the intersecting row and column intersecting element. So obviously minus 3 is the pivot element. In next step, next tabular column, step 1 iterative 1 or step 1, next iterative 2 or step 2. So CB, YB, XB, Y1, Y4, Y3, Y4. So X4 leaves and X2 occur because the row and column intersecting element column is Y2. So obviously next step Y3 and Y2 occur. Okay. So what is the ideal element in the next tabular column? The ideal element become 1 and the corresponding values become 0. So how can we become 1? You have to divide the same element with all the rows. So all the elements in Y4 divided by minus 3. Y4 divided by minus 3. So how? So minus 2 by minus 3 is minus 2 divided by minus 3 is 2 by 3 plus 2 by 3. This is also getting same value, minus 2 by 3, 2 by 3, 1, Y2 become 1, this is 0, this is 1 by minus 3, 1 by minus 3. And the corresponding elements getting zeros. By which process you have to add the corresponding elements with the pivot element, then we get the corresponding elements become 0. So how can we change the pivot element for become minus 1 getting 0? So minus 3 convert into 1. How can we convert minus 3 into 1? So you have to multiply 1 divided by minus 1 divided by 3. So Y4 into 1 divided minus 1 divided by 3. So Y4 into minus 1 divided by 3 plus Y3. Now what are the elements present in Y4? So first element, the XB value is minus 2. So minus 2 into minus 1 by 3, because Y4 into minus 1 by 3 plus Y3. So minus 2 into minus 1 by 3 plus minus 1, that is 2 by 3 minus 1, that is 2 minus 3 by 3 is equal to minus 1 by 3. So minus 1 by 3. Next value minus 2, again minus 2 into minus 1 by 3 plus the same repeated value. So obviously we are getting minus 1 by 3. So what is the third value? Minus 3 into minus 1 by 3 plus minus 1. So plus 1 minus 1, we are getting 0. Y2, the corresponding values of the pivot element become 0. Next value 0, obviously 0 into anything is a 0 and add plus 1, so answer is 1. So 1 into minus 1 by 3 plus 0 is minus 1 by 3 in last value. So likewise we have to the corresponding element of the pivot element 1 become 0 in this second iterative tabular column. So how can we make 0? You have to add the pivot element to become a 0 in the corresponding element. So how is it possible? So you make anything to the pivot element. So you want -1. So -1 into 1 by 3. So y4 into 1 by 3 plus z. So y4 into 1 by 3 plus z. So y4 -2 into plus 1 by 3 plus 0. So -2 by 3 plus 0 -2 by 3. First value -2 by 3. Second value -2 into 1 by 3 plus 3. That is -2 by 3 plus 3 -2 plus 9 by 3. That is 7 by 3. So next value -3 into 1 by 3 plus 1. That is -1 plus 1 getting 0. So y3, y4 obviously 0. So 0 into anything 0 and add 0, you are getting 0. So 1 into 1 by 3 is a 1 by 3. Now we see the xb value. In all the xb values are getting positive, then the problem will over. Otherwise, we proceed into the next tabular column. The process is repeated because the one for negative value occur. One negative value occur in the xb value. So the problem is continuous in next step, next tabular column. Now we have to choose the xb value in comparing these two values, that is the -1 by 3 and 2 by 3. Which one is the most negative or least negative? -1 by 3 is the least negative. So you have to choose the y3 row in next step, step 3, that is iterative tabular column 3. CB, YB, XB, Y1, Y2, Y3 and Y4. So you have to select these Y3 row because of these two value, most negative or least negative. So -1 by 3 and 2 by 3. So comparing these two values, so -1 by 3 is the most negative. So you have to select the y3 and finally we choose the column value. So Zj minus Cj value 7 by 3 divided by -1 by 3. Maximum of 7 by 3 divided by -1 by 3, that is -7, and this value 0, 0 by anything 0. So 1 by 3 divided by -1 by 3 is -1. So -7 and -1, the maximum value is -1. So obviously we have to select this column, y4 column. So what is the pivot element? So -1 by 3 is the pivot element. In next step, in y4, -1 by 3 become 1 and the corresponding elements, these two elements become 0. These are the conditions for the dual simplex problem. So how can we convert? So -1 by 3 become 1. So you have to divide, you have to multiply -3. So y3 into -3, then we are getting 1. Minus into minus plus, 3 getting cancelled. So we need 1. So in a first element, what is first element? -1 by 3 into -3. So xb value 1. In First step, y3 leaves and y4 enters y2. So 1. Next step is also 1. Next is 0. 0 into anything? 0. 1 into minus 3. Minus 3. So minus 1 by 3 into minus 3, we are getting 1. And the next value, the corresponding minus 1 by 3 become 0. How can we we have to add the pivot element and we get the 0 element. So how can we into minus 1 by 3, that is y3 into minus 1 plus y2, that is y3 minus 1 by 3 into minus 1 by 3 into minus 1 plus y2. y2 is 2 by 3. So 1 by 3 plus 2 by 3 is 3 by 3. 3 by 3 is 1. Next 2 by 3. 2 by 3. So next is also 1 by 3. Next y3 value minus 1 by 3, the same. Minus 1 by 3, 2 by 3. So 1. Next value is 0. 0 into anything is 0. And add 1. So 1 into minus 1. So minus 1 plus 0. So minus 1 by 3 into minus 1 plus minus 1 by 3. So plus 1 by 3 minus 1 by 3. Obviously, the corresponding values become 0. Next is Z. You have to add these two, automatically will get 0. So you need not to multiply any number to the pivot element, just you add. So minus 1 by 3 and minus 2 by 3. Minus 1 by 3, minus 2 by 3, minus 3 by 3, minus 1. So minus 1 by 3 plus 7 by 3. Minus 1 by 3 plus 7 by 3, that is 6 by 3, that is 2. 0 plus 0 is 0. 1 plus 0, 1. Minus 1 by 3 plus 1 by 3, get 0. So now we see the XB value. In XB value, only the positive value occur. If the negative value occur, you repeated the same process until you get the positive value. In this problem, the XB values become positive. So the problem will be over, finished. So XB, Y4 equal to 1 and X4 equal to 1 and X2 equal to 1. X4 and X2, J. Maximize Z equal to minus 1. In problem, given problem, only minimize Z. You have to convert the maximize Z into minimize Z. So minimize Z equal to 1. I hope the problem is finished. I hope you all understand the dual simplex problem. In next class, we will discuss another one example of this same method. Thank you, students.